Hi, I'm Brian Bunce. I'm the Content Director of the IoT Institute. I'm here today, this week at IoT World. I have with me Lynn Neese. I'm Chief Technology Officer at HPE. Welcome, Lynn.
Oh.
Nice meeting you.
Nice meeting you.
So can we start off by having a description of your organization and your role at HPE?
So I'm the Chief Technologist for IoT for the HPE Enterprise Group. And my organization has several businesses, both infrastructure and services, that are related to Internet of Things.
So you gave a keynote this morning titled Reality's Digital Twin. What is it that you think is important about digital twin, and what should people in the IoT space know about them?
I think that digital twin think of it as the digital rendition of the physical world that is being rendered by software. And in our view, what's critical for the evolution of the digital twin is that it goes from being a collection of separate data items that are somehow processed and interpreted in event processing or by out-of-band software to being more of a cohesive, stateless, completely self-sufficient piece of data that does not require so much integration work.
What is your favorite example of a digital twin?
So I would say, there are data structures, time series data, for example, coming from, let's say, a parking meter. That can be quite simple. A trash can would be another example where is that trash can and is it full or empty? And it's an extremely elegant interpretation of digital twin, and the data is incorporated in a data store that is actually quite minimal in nature. A digital twin is more or less what you make it.
So could you tell me a little bit about HPE's innovation labs and what you guys accomplish at them?
So HPE actually has what we call our IoT Discovery Labs, and we have them in multiple geographies. We have them in Geneva, Switzerland. We have it in Houston, Texas. And what we're accomplishing in these labs, this is where we actually test our partners' software running for real customer proofs of concept. And we've actually kept these labs quite busy as a result, because a lot of the projects in IoT, our customers don't know what kind of return on investment they're going to get for these new types of use cases and capabilities.
So it kind of helps them scope out what they can plan for.
Absolutely, and understand whether or not there is the benefit they're expecting.
What can you tell me about your partnerships? I understand that you guys are working closely with GE, for instance. Can you speak to that, maybe a couple others?
Absolutely. So our heritage is in the IT world, and we have partners who've long been customers of ours, OEM customers of ours, who have sold software into the operations technology world. So if you think of an example like a General Electric, great example in fact, our partnership with them is as they try to move towards consolidating their software onto the Predix platform, we're partnering with them to be the underlying IT layer that makes Predix work and makes it process ready for the IT world, which will inexorably get involved in these projects.
So on a related note, I understand that HPE is one of the earlier edge computing players. I'd like to hear some more about your strategy in edge computing.
So we've come to realize, and I think the world has come to realize, if you look at a typical smart cities project, 70–80% of the data is just raw video data. We're generating raw video data as we speak, in fact, and there's a tremendous cost to managing all the data that is generated from an aircraft flight, which could be terabytes of data coming off of a jet engine for a single flight, or raw video data from a smart city where I have cameras on top of every light pole on every street block. Why would we use up the precious wide area network bandwidth and the organizational issues and management issues to store that data centrally when it can remain in a more raw form at the edge and be processed on demand? And so in our view, the edge represents where probably most of the data will live. And we've seen reports where studies have said 40% or more of the data will stay at the edge. It's probably more like 99% of the data if you think about raw data in that term. So from our perspective, the physics of IoT will force edge computing to be critical. And the proximity of the compute gear and the storage of the data from the physical world will need to be more on-premise in the future, and we know this. And how to make that cost-effective and how to make distributed computing more manageable is critical to our strategy.
So for a final question, I'd be curious to hear your opinion on the overall IoT adoption in 2017. Like, what do you see changing this year?
So we're seeing a big uptick in the use of analytics for things like predictive maintenance, we'll call it. There's predictive analytics, there's predictive maintenance, there's condition-based monitoring, and we're seeing extensive use of analytics for those use cases, and that uptake is happening right now. And in many cases for us, it involves partnering with some of these operations technology companies who we talked about earlier, industrial companies who have asset performance management software that they're now moving into a more connected device world. At the same time, we're seeing a big uptick in connected smart cities. And there seems to be a strong push on the part of many large urban areas to create a digital foundation for the physics and the flows that are inherent to smart cities.
Thanks, Lynn, for joining us at the event. Glad to have you here.
I'm very glad to be here. Thank you.
Thank you.